Hi there guys, got a video here for you today on the AGT Manul, and what we're going to be doing in today's video is making a new trigger blade for the pistol. When it's all said and done, it should look something like this, and this is just a 3D printed prototype that I made up just to check the dimensions and make sure everything is going to fit how I want it to. Now there is nothing really wrong with the factory original trigger, although I will say I do prefer a flat fronted trigger, and I am going to be adding some grooves in the front just to give it a little bit of extra grip. With that all said, I'll take you over to the mill and we'll get started on the work. Right then, so moving over to the mill, the first thing I've gone ahead and done is just got a square piece of stock held in our milling vise. With that done, we're coming through with a nice big face mill and just milling off the top of the part so that we have a nice surface finish on the top and we have a good flat surface to work from. Up next, we can start work on the perimeter of the trigger body, starting with a 5mm carbide end mill, milling both the datum faces and zeroing out the digital readout. The datum faces in this operation are this front face that you can see here and the back face. With both of those milled, we can mill the trigger body to size, simply milling the other sides of the part down until we reach the correct reading on the DRO. The overall dimensions should be 20.6mm wide and then 29mm long, ensuring that we have a good finish on the side walls, although I will say most of this material will be removed in further operations, so it's not super critical. Moving on to the back of the trigger body, I need to remove some of the material along this back section, and this area will be hidden by the side cover on the pistol. Ultimately, this flat section will house the trigger weight and first stage travel adjustments. In total, I'm taking about 6.5mm from the back, leaving a small nub of material about 5.6mm wide at the front. And again, all this material is removed using our 5mm 2-flute carbide end mill. A similar operation can be carried out along the front of the trigger blade. I need to remove another 2mm of material from the front. This moves the front of the trigger back a little, and it also allows the trigger to pivot without hitting the pistol body. Right then, so that's the perimeter of the trigger body milled out. The next thing we need to do is drill the 4 holes in the trigger body. So the 3 on the side there are just decorative. They serve no real purpose other than to make the body of the trigger look a little more interesting. And then this one at the top here is the rotation or the pivot point for the trigger. So this is going to be drilled and then reamed so that it's a nice fit on the pin. To get the position of the holes, we're going to be using a coordinate system. So when we milled the perimeter of the trigger, we used this side and this side as our datum points, and then we milled this side and this side to suit those references. For the position of the holes, we can again use this corner as we're already zeroed out on it. So we just need to drill our hole in this position, then the 3 along the body. Once I have the hole positions marked, firstly I can come through with a center drill to spot the hole position. Then, for the first hole, I drilled about 13mm deep using a 1.7mm drill bit. Then, to make sure that the hole was nice and round and not super oversized, I opened that out to 1.9mm, again using a nice sharp twist drill. Lastly, this hole can be reamed using a 2mm reamer. And again, this needs to be reamed as the trigger will rotate around a pin set in the pistol body through this hole here. Up next are the decorative holes in the side. Again, the hole positions are set out using a center drill first, then a 2.6mm pilot drill is used to open out the holes. The finished size of the holes is 3mm, and to finish that out I just used a 3mm drill. Stepping the hole out slowly improves the surface finish on the inside of the hole and makes them look a little nicer. Once all holes are drilled, the last thing to do on this side was to very lightly countersink each of the holes, and when the part is finished to its final width, I'll just do the other side just using a handheld countersink. Right then, and that is the holes drilled. We've pretty much done all we can do in this particular setup, so the next thing I need to do is separate the trigger from the parent stock, and then start work on the other side and the other features. To remove the trigger body from the stock, what I'm going to do is just cut it off with a hacksaw. We've got about 2mm of material along the bottom here, so it's not particularly tight. So I'm going to quickly get that done off camera, then I'll bring you back when we're working on the other side. Once the part was cut off, the next step was to flip the part over and get the trigger blade milled to thickness. You can see the trigger held in the mill vise on top of a set of parallels with a piece of brass square held between the part and the vise to allow me to clamp firmly on both sides. This just reduces the chance of having the part ripped out the vise by the face mill, as if I were to clamp on the back face and the small nub, there would not be a lot of material to clamp a hold of, and the part could be grabbed by the face mill. To measure the part, I'm using a small micrometer. Normally you just see me use a set of calipers, but with a small item like this, it's easier and more accurate to use a micrometer. The final thickness should be just over 7mm, and I was aiming for about 7.05. That should be a nice close fit within the block, and there will not be any side-to-side play on the trigger blade. With that done, the next thing to do was get the adjustment screw holes put in position. There are 2 adjustment screws on the blade, one M3 and the other M5. First, the trigger blade was set up on a parallel in the vise, then the vise was tightened and the parallel was removed. I will be drilling all the way through and I don't want to damage my parallels. There's not a ton of downforce on the part itself, so it shouldn't move within the mill vise. Next, I just came through with my edge finder, found the edge of the part, then got myself set up on the center of the trigger blade. The 2 holes are nice and easy. The first one was an M3 hole. To get that put into position, I first center drilled the hole location, then drilled through with a 2.5mm twist drill, which is tapping size for M3. The hole was then given a generous chamfer, and the trigger blade was tapped using a split flute tap. A split flute tap pushes the chips through the bottom of the hole, and typically you only use these taps on through holes. The M5 tap was done in pretty much the same way, although a 4.2mm drill was used for the tapping hole, and instead of a split flute tap, I used a spiral flute tap. A spiral flute tap forces the chips out the top, rather than pushing them down through the hole. And as you can probably guess, a spiral flute tap is generally used on blind holes, although they can pretty much be used in most applications. There is no real reason for me using 2 types of taps here, I just wanted to show you the difference between the 2 types. The next job was to finish off the front of the trigger, so I wanted this to be a flat face trigger and for it to look a little different. What I chose to do was a grooved pattern on the front with a heavy chamfer on the sides, just so the sides didn't dig into my finger. The first job of the operation was to mill a small pocket out from the front, about 14mm wide and 1mm deep. This is a little narrower than the width of my finger, and it should be just wide enough to cup round the pad of my finger. Next I came through with a chamfer mill and just put a light 1mm chamfer on each of the walls along with the sides of the blade. There was no real thickness in mind, I just milled it down until it looked and felt right on my finger. For the grooves themselves, I switched over to a 60-degree chamfer tool, which is slightly narrower than the 90-degree one I was just using. The grooves were cut about 2mm apart, and in total they were milled about 0.75mm deep. The first pass produced an absolutely horrible surface finish, although this was expected as these tools are generally run much faster than this mill will run. But a second pass through the slot and then a couple of passes along the sides of the groove soon cleaned things up nicely. To finish things off, I used a small file to clean the edges of the grooves, just taking off the burrs and making the side profile nice and clean. With that part all finished, the front of the trigger feels fantastic in the finger. It's not too sharp, but it does have a certain grip to it. Exactly the type of thing I was going for. The final job was to cut the rear section away. This isn't a critical dimension, so I just used my 3D printed prototype as a guide, lining the holes up with a drill bit and marking it using a metal scribe. The angle that we cut on the back of the trigger is just for clearance, so it doesn't have to be at a specified angle or anything like that, but it does stop the back of the trigger coming into contact with the body of the pistol. But with it all marked up, I just clamped the trigger body in the vise, lining the scribe mark up with the top of the vise jaws. Then once I was happy, I just milled the top off using a 10mm end mill. With that all said and done, that's pretty much project complete. So we'll move over to the mill and I'll get you a good look at the trigger blade fitted to the pistol. Right then, so that's the trigger blade finished for now and fit to the pistol. It's not 100% finished yet, I still do have to anodize it black, and I may alter the profile very slightly. What I'm thinking of doing is taking this bottom corner off here and making it in line with the trigger guard here, just so it fits the profile of the pistol a little better. Once the blade itself has been anodized black, it should look a little less blocky as well, although I do quite like the blocky look as it fits with the rest of the pistol quite nicely. And what I may end up doing is just laser engraving the Sub 12 Airgunners logo in the back here, just to make it a little more interesting, but we'll see how it looks when it's black. We still do have access to the adjustments if we upend the pistol. You can see that we still have adjustments to the trigger weight and first stage travel at the back there. We can still adjust them nice and easily, and the trigger fits really quite nicely with it in my finger just there. So I'm really quite happy with how that came out. I think it's a nice little mod. But with that all said and done, that's pretty much going to do it for this particular video. So thank you very much for watching. I hope it's been interesting or useful. And I'll see you in the next one.